This is a demo of using the interference analysis API from the command line with some mock data. So we've created two networks here in the UK for S-band radios on the ground. And to start with, the two networks are going to be balanced. They're both going to be using 1 watt of power. So we've got a script that's written in Rust here that interfaces with our API and SSRF documents. So that's the XML document here. So in this document, we've described some radio networks and random locations. So we run this now. It's going to do 2 multi-site requests to model the networks, which will make us some KMZ files in a folder here. And as they're going, we can chuck them on the map and see network A and network B. So there's 2 networks on top of each other. It's quite messy trying to interpret what's going on here. These networks are separated in frequency by 4 megahertz, and they're only using 2 meg of bandwidth each, so there is a guard channel between them. We've got the interference layer here for the first network, and we can see only a tiny bit of interference on the fringe where the signal is very weak. There's a geographical feature there. Same with the other network. Tiny bit of interference at the edge where it's very weak. So that's okay, that's acceptable. Let's just have a look in this file here, and just to show you what the some of the XML looks like. This is the ERP in this file. There's 2 assignments in here for a high power network with 50 watts EIRP and a low power network still at 1 watt. So we're going to run this next file now, and this time they're unbalanced, so we'll see what happens. So same again, we model the networks first. So there's a very powerful 50 watt network and a less powerful 1 watt network overlapping. So let's pull in the interference layer, and first of all we see that the powerful network is experiencing no interference, as you might expect. The real subject of interest is the low-powered network. Let's pull that on and look at the impact of the high-power network. Despite being 4 megahertz away in the spectrum, it's causing quite a lot of interference, and it's really intruding onto the network now, especially where signals are weak. And so the interference here is significant, and we've modeled it straight from SSRF XML documents into something that's very easy to consume visually. Please note the color key here is for the multi-site calculations, not the interference, which uses a JS ratio where green is good and red is bad.